Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem majority element 2. So this problem is just similar to majority element 1. You can go and watch my tutorial how I solved majority element 1 with the most intuitive way. You can just check out of it and understand majority element 1 because we will use the same code here. We will just copy and paste the same code, not copy paste. I will code it, but the code is same. Just we have to handle some edge cases. You must watch and you must go and watch on YouTube about the majority element 1. All right, I have solved it. So the problem statement says that here, given an integer array of size n, find all the elements that appear more than floor of n by 3 times. So nums array is given 3 to 3. Now we the in this case n is 3, so floor of 3 by 3 is 1. So we have to find all the elements which are appearing more than 1 times. So here 3 is appearing 2 times and 2 is appearing 1 times. So we can say that 3 is appearing more than 1 times. So majority element is in this case 3. Next, n is nums arrays containing only one element 1. So n is equals to 1 and floor of 1 by 3 is 0. So we have to find any element greater than 0. So 1 is appearing more than 0 times, so majority element is 1. And next, nums is containing 1 comma 2, so n is here 2 and floor of 2 by 3 is 0 again. So we have to find all the elements which are appearing more than 0 times. So 1 and 2 are appearing 1 times, they are appearing more than 0 times, so the majority elements are 1 comma 2. So we have to first observe at max how many elements will be there who are appearing more than floor of n by 3 times. Suppose we have total 100 elements, and what will be, this is n, what will be floor of 100 by 3? The floor of 100 by 3 will be 33. floor of floor of 100 by 3 will be 33. So we have to suppose we have to found at max how many elements can be there who are appearing more than 33 times, and we have to found maximum number of elements. All right, so let's take an example. Suppose 1 is there and he is appearing more than 33 times, so minimum he should appear 34 times. Next, suppose 2 is there and he is appearing more than 33 times, that is appearing 34 times. Now how much left? So we can say that there is only 32 left. So let's say any element 3 is there, he is appearing 32 times. So can we say that there are only two elements at max which can appear more than 33 times, that is 34 times. So in any case we can say that if first I should slide it here. So we can say that at max there will be only two elements who are appearing more than floor of n by 3 times. So this is the great observation also, that in majority element 1 case we have seen that elements if you have to find any number of elements which are appearing more than n by 2 times, there was just only one element. In this case we will find only two element, and in n by 4 case we will find only three element. So can we say that any element This is just extra information. Any element, this will be k times. Maximum element that can appear more than n by k times will be k minus 1. So in n by 3 also, we at max we will get only 2 elements. All right, this was just extra information. So now we have to solve this. So what could be the most brute force approach? So the most brute force approach will be just using frequency array or hash maps. We can use them and check which elements are appearing more than floor of n by 3 times, but they will be okay with big of n time complexity, but they will also contain extra space of big O of n. If you are using frequency array or unordered map or map, they will take extra space complexity of big O of 1. But we can see here that in the follow-up it is given that could you solve the problem in linear time and in big O of 1 space. So we have to think of big O of 1 space. So similarly, I will be using the same code that I have explained in majority element 1 by using Boyers-Moore voting algorithm. You can just go and check that video, majority element 1, and we will just use the same voting algorithm here. So in this case, what we will do, we will just use the same. Let's say in this case there are 3 parties and we have to, at max 2 parties will be winner. So let's say winner or element 1 will be something, element 2 will be something, winner 1, these are the winners. Let's take winner only. So winner 1, winner 2, initially they will be null. I will be using the same voting algorithm, and for if you have to check what's that algorithm, you can just go and check majority element 1 video. There I have explained the Boyers-Moore voting algorithm very intuitively using election and voting example. So we have to make count also. We will keep count also, number of votes, count 1, count 2. Initially they will be 0 or they will be initially null. All right. So suppose a person came and gave vote. The first person came and gave vote to A. So we can say that our winner is for now A, and let's say that our second person came and gave vote to again A. So we can say that our winner was A, and yes, we have to increase count also. And now the second person came and vote again to A. So we have to increase count of 1 again. So this will be increased by 1. Third person came and gave vote to C. So we will say that our winner 2 is C and count will be increased to 1. Now fourth person came and again gave vote to C. Count 2 will be increased by 1. And alright. Now fifth person came and gave vote to, let's say, B. So using the same voting algorithm, we will decrease count. Alright. But in this case, we will decrease count of both by 1. Now this will become 1. Now sixth person came. We will assume that there are only 10 voters. So now the sixth person came and gave vote to, let's say, again B. So now our count will decrease to 0 again. Both counts will decrease to 0. Now in this case, when count is 0, anyone count is 0, now our winners will again be reinitialized. Now our next vote goes to this A. So not A, this was already A. So let's say that our next vote goes to, let's say, B only. And now our winner 1 will be B. Alright, and our count will be increased by 1. Our next vote goes to, let's say 8th vote goes to A. So our winner 2 will be initialized to A again, and count will be increased by 1. Now next, 9th, let's say our next vote goes to C. Now C is were different from the both the winners, so we will just decrease our count again to 0. Alright, so again our 10th voter came and gave vote to, let's say, 10. So we can see that count is decreased to 0, so we will reinitialize. So the vote is to the 10th vote is given to A. So we will say that winner 1 is now A. Alright, and count 1 will be increased. Let's increase our sample test cases also, because we to explain it clearly. Next vote again goes to, let's say, B. So this will be again B, and this will be increased by 1. And third vote, let's say, again goes to 12. 12th vote goes to A. So we have to increase count of A. So let's say there were only 12 voters. 12, n is equals to 12, let's say. Now at end the winners we will get will be only the winners. So what I did in this voting algorithm, I have just used the same voting algorithm. What I did in majority element 1 case, we will just copy and paste the same code here, because it's just the same intuition and same logic we will use here. So but we have to handle some edge cases. Suppose our count 1 was 0. Suppose our count 1 was 0. Suppose this was 0, count 1 was 0, or alright, and count 2 was something, it was something. Now whenever, now it means our count 1 is 0, it means we have to reinitialize our winner 1. Now this will be winner 1 will be reinitialized. Suppose the next voter came and gave vote to B. So what we will say, that our now winner 1 is B, but we can see that winner 2, where B was already a winner. So in this case, when we will when we will just forcefully uh, say that again the next voter came and we will say that our winner is B, we should not do it. We should first check that if B is already the winner, if B was already the winner, we should increase the count of B only. And if B was not the winner, if any other winner was declared, I mean, we have to check that. So if the count 1 was 0 and we have to reinitialize the winner 1, we should check that if the winner 1 which we are declaring now has not been winner already, because in that case we have to increase the count of votes to that B, not initialize again winner 1 to B. We should not do this. We should just go and increase the count of B. And yes, if any other winner comes, C or A or any other party comes, we will just say that yes, winner 1 is A now or C now. Now we will just increase the count of 1 then. But just only this case we have to handle, this edge case, that if we are initializing winner 1, we should always check that it's not have been already a winner. Alright, in that case we will just increase the count of votes for that winner, because both winner 1 and winner 2 should be unique, they should not be the same. All right, so this was the intuition. So this was just a very simple logic. You can just check my majority one element video also and just understand from there what was that Boyer-Morris voting algorithm, and we will just copy and paste the same code, just some small edge cases that I told you, winner and winner 2. You have to check that winner has not been initially a winner, it should be a new winner. All right, but this, just this edge case we have to handle, nothing else. So I will go to the implementation part now. So similarly as we do in majority element one case, I will just declare the size of the nums array, and now here we will get at max two winners. So we will say element 1 is equals to null for now, and element 2 is also is equals to null for now, and now we have to count also. Let's say count 1 is equals to 0 and count 2 is equals to 0 for now. Now what I said, I will go to the entire array and just check the same code. There we used to do if count is equals to 0. In this case we have to check if count 1 is equals to 0. I will say that I have got my new winner. Element 1 is equals to nums of I, and C and T. Count will be initialized to 1. Similarly, in the else if case, if count 2 is equals to 0, we will handle the edge case also. I'm just first copy pasting the same code. I'm just copy pasting the same code that we used to do in majority element 1. Logic is same. We have to just observe the pattern. Questions problem will be solved according to that pattern only. We just have to observe that pattern and apply that pattern. Alright, this will be count 1 and this will be count 2. Count 1 will be initialized to 1. Count 2 will be initialized to 1. Now in this, when we are when our count 1 is 0, we have to reinitialize our winner. We have to just make sure that it's not been already a winner. So we have to just check that the winner which we are going to declare should not be already a winner. This should not be equal to element 2. Similarly here also, this should not be already a winner. Element 1, if I am using the correct variable names, yes. Now similarly else if case, if nums of I is equals to 11, we will just increase the count of that winner. Similarly, if nums of I is equals to elu2, we will increase the count of elu2. Else case, when we have got another party, another vote to another party, we used to decrease the count. Here we will decrease the count to both the parties, for both the parties. Now after ending this for loop here, so now at last we will check also that the frequency of both the elements which we have got is more than floor of n by 3 times or not. Alright, because in this question it is not given that we are sure that there will be two elements. Alright, so we have to check also at last that both elements are occurring more than floor of n by 3 times. We can just reinitialize our count, or we can use another variable frequency, but I'm using the same variables, and again we will just run a for loop, and we will check that if nums of I is equals to 11, we will increase the count of 1, or if nums of I is equals to elu2, count of 2 will be increased. Now here we have to return the answer in vector form. We have to return both, all the max majority elements. At max there will be 2, so I can use a vector of integer answer, and we will push back only that element who is occurring more than floor of n by 3 times. So I will check that if element 1 count of element 1 is greater than floor of n by 3 times, then I will push back the element 1. Similarly, if count of 2 element 2 is greater than n by 3 times, I will push back the element 2. But here we have to handle one more edge case, that the element should be unique. Both elements we are checking can be same also, can be duplicate also, but we have to return the elements uniquely. So we should check that element 2 is not equal to element 1, that duplicate case. Suppose both elements are, suppose all the array is, whole array is containing zeros. So in this case our element 1 will also be 0, and element 2 will also be 0. That's why we that's I mean, this is just an safe case for checking that duplicate elements are not in the array. So we can just now return answer, and also for we can just manipulate here if and else cases. But what I want here, that I just want to copy and paste the majority element 1 case. That's why I just used here the same code here, and just adding some 1 to 2 edge cases here, we can see that our problem is solved, and we have solved this correctly by just using the same majority element 1 case 1 code, majority element 1 code, by just modifying the some parts. At max 2 elements are there, so I declared 2 variables and just added some if and else cases similarly that we used in majority element 1, just adding edge cases here, this edge case, and here this edge case, that and this here this edge case. Just adding one simple edge case, we can just solve this majority element 2 also. And similarly, this is a pattern. We have understood here the pattern, how voting algorithm works. Now we can solve majority element 1, 2, or if any question comes that asks for find all the elements that appear more than n by k times, we can solve now. We have understood the pattern. So time complexity and space complexity is also, if I talk about this, is also big of n similarly, because we are using one for loop, and yes, we are using 2 for loops, so the time complexity is approximately big of any n only. And space complexity, we are just declaring variables, so space complexity is big of 1. So this was all about this problem. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.